Let's practice some questions based on the refraction and laws of refraction we studied in the last video. The question is, the refractive index of glass is 1.5, mu of G is 1.5, mu of water is 1.3, speed of light in water is 2.25 into 10 raised to power 8 meter per second. We need to find V of G. Let's solve. We know that mu G will be equals to C by Vg, and we have to calculate Vg. So mu G is given 1.5 and this is 3 into 10 raised to power 8 by Vg. So Vg will be 3 into 10 raised to power 8 divided by 1.5. 1.5 could be written as 3 into 10 raised to power 8 divided by 3 into 2. 2 into 10 raised to power 8 meter per second. This could be the method, or you can use like this: mu G is equal to C by Vg equals to 1.5, mu W equals to C by Vw equals to 1.3. Compare them, as C could be written as 1.5 Vg and here C could be written as 1.3 Vw. Compare both values. 5 Vg equals to, this is 2.25 into 10 raised to power 8. So Vg equals to 1.3 into 2.25 into 10 raised to power 8 divided by 1.5. Remove the decimals. 110. 5 and 3, 5, 4, 5, 3, 15. So 1.3 into 15 into 10 raised to power this 6 and 1 7. So it becomes on calculation 1.95 into 10 raised to power 8 meter per second, which is directly approximate. If we do, it is 2. Question 2 is, light of wavelength 6000 angstrom in air enter a medium with refractive index 1.5. What is the frequency and wavelength? Frequency and wavelength in the medium. Six into 10 raised to minus 7 meters. Now you and we know that frequency is equals to C by lambda. You know lambda, you know C. Calculate the V. 3 into 10 raised to power 8, 6 into 10 raised to minus 7 will go up. You can write it as 10 by 2 into 10 raised to power 14. This is frequency, and the units of frequency are second inverse. Now wavelength of the light in medium. So mu will be equals to wavelength of light in vacuum divided by wavelength of light in medium. This is 16 to 10 raised to power minus 7. Lambda dash we don't know, mu is 1.5. Lambda dash will be equals to, we can take it as this also, or you can say 6000 angstrom only, because wavelength will be in angstrom. 6 into 10 raised to power 3 angstroms. Okay, so open it. 3 2s are 3, 5, 5 into 2. So answer comes 4 into 10 raised to power 3 angstrom, or 4000 angstroms. Next question is monochromatic light of wavelength. This is incident from air on water surface. What are the wavelengths or frequency and speed of light reflected and refracted light? Refractive index of water is this. Given is wavelength of light in air is 589 nanometers, means 589 into 10 raised to power minus 9 meter. Okay, then we know that refractive index of water is 1.33. We need to calculate wavelength, frequency, speed of reflected and refracted ray. Okay, basically the wavelength of reflected ray will be same, because reflected ray, the length of wavelength of reflected ray will be equals to incident ray. So wavelength when reflected will be equals to 589 into 10 raised to power 9 meter only. And after reflection, light travel in the same medium, then velocity of light after reflection will be again equals to c 3 into 10 raised to 8 meter per second, and frequency will be c by lambda. Frequency 3 into 10 raised to power 8 divided by 589 into 10 raised to power 9. Approximately the answer will be 5 into 10 raised to power 14 hertz. Now when refracted, when it is refracted, now after refraction frequency do not changes, so frequency will remain same 5 into 10 raised to power 14 hertz. And we will calculate the velocity by c by mu, because we know that mu equals to c by v. 3 into 10 raised to power 8 divided by 1.33, which is approximately equals to 2.2. 5 into 10 raised to power 8 meter per second. And third is wavelength. Wavelength in water will be equals to, you can from here you can derive that it is v by frequency. Okay. 442. Here will be 9. Okay, sorry. 93 nanometers.